This is a 4,000-pound eVTOL aircraft with 8 motors and rotors. And there's 4 rotors on the top that are coupled to one battery, 4 rotors on the bottom coupled to another battery. They're counter-rotating at each corner. And the aircraft takes off vertically with those nacelles pointed 90 degrees towards the sky. And as it rises into the air, those nacelles tilt forward and it starts to accelerate forward. As it accelerates forward, there's a shared lift between the rotors and the wing. And as those approach 0 degrees, you turn into a regular old airplane. And the power comes way down because the lift is being produced by the wing and the thrust is being produced exclusively for forward motion by the rotors. Inside the aircraft, there's a flight controller that determines the distribution of propulsion to every one of the rotors based on its position and the direction of the rotor. So for example, to do a yaw maneuver where you're going to rotate about the z-axis, you modulate the power independently to all the clockwise and counterclockwise rotors such that the anti-torque starts spinning the aircraft in the other direction. So you can imagine that the rotor that has a large moment arm pushing out in this front right is sweeping you through the air with a little bit more power than the returning blade on that. So to turn to the left, you turn on all of the clockwise rotors a little bit more. To pitch forward, the rear rotors add some power, and to pitch left and right, the counterposing side, of course, adds power. The goal of this aircraft was strictly to elicit critical thinking about electric aviation. And the best way to do it was to build something. So United Therapeutics and us partnered to design and build this aircraft and attempt to fly it across the country because it would expose all the hard problems associated with eVTOL, from designing and building the aircraft to getting the pilot's licensed to fly it, all the way through the regulatory challenges of flying it airport to airport across the country. So it's designed ultimately to carry organs from a manufacturing facility to hospitals, but the form of this aircraft is not the form of the aircraft that will be doing that. The flight controls, a lot of the technology developed to develop this aircraft will of course be used, but the shape, size, and form of the aircraft will change for the commercial version. Everybody is pretty excited about the opportunity to use super efficient electric propulsion and fly short hops from suburban to urban areas, for example, and relieve traffic congestion. So this type of aircraft could certainly do that.
Well clear on the left.